The fall is from a height of 7 inches to break the ore fine enough to pass through a screen with 3/4-inch openings. These machines are called rod mills, revolving cylinders 12 feet long, 6 feet in diameter. Round and round, 10 of them breaking the ore to pieces smaller than a grain of wheat. Here's what's going on inside. 35,000 pounds of steel rods hammering against 28,000 pounds of manganese steel plates, whirling around 17 times a minute. Tough going for the ore and for the steel rods too. This is what a 10-foot rod looks like after going through the mill. In the rod mill, much of the ore is ground fine enough and requires no further grinding. And this machine, called a classifier, floats the fine ore out and sends it on its way. Periodically, a measured quantity of quicksilver is fed into the mills. This laboratory demonstration shows what takes place in the rod mill. Quicksilver and gold brought together form a grayish, putty-like mass called amalgam. The heavy amalgam settles to the bottom of the pulp to be captured on a copper plate which also has been treated with quicksilver. Yes, sir, there's the first sign of gold we've had, but you'd never know it to look at it. The amalgam is softened by the addition of more quicksilver and cleaned up in this hydraulic press. All ready now for a last change of face into gold. The crushed ore is now leaving the rod mills on its way to the ball mills, where 2-inch balls pound and grind and pound the ore so fine that 2/3 will pass through a 200 mesh screen. How fine is that? A square inch with 40,000 openings through which the sand must pass. The heavy material on the right is a sifting cloth used in flour mills to sift flour. Fine enough for flour, but it can't compare with the even finer mesh used in sifting the mill sand. These classifiers separate the sandy part of the ore from the overflowing slime. The overflowing slime is piped to another plant for special treatment. The sand is raked out of the classifiers to go on its way to the cyanide tanks. Lime is added to the sand pulp, another step in the chemical control of this complicated process. Water, water everywhere, and not a drop to drink. But what you see going into that tank is gold-bearing sand. The water just helps it along. There are 28 of these redwood tanks, each holding 700 tons of sand. 8 hours to fill a tank, and 20 to drain the water from it. Then the top must be raked. Why? To prevent caking, and then air is forced up through the sand to provide oxygen necessary in the cyanide treatment. The incoming cyanide solution goes on dissolving the particles of gold left in the sand after amalgamation and liquefies it. It's hard to imagine gold being dissolved in a liquid like sugar in your coffee, but that is exactly what cyanide solution does. It turns gold into liquid. And there it is, liquid gold. Gold in solution. And the solution in that bottle is worth about 2 cents. But what about the sand? Man-made erosion, washing it away, returning it to the mine for filling the stopes from whence it came. This tank holds 200 tons of gold-bearing solution, gold taken from finely ground ore by the action of chemicals. Remember the slime, that clay-like substance floated away in the classifiers? Here the last minute particles of gold are taken from it in these great presses. Here is a department that is highly important, the assay office. From the time the ore is mined, samples are taken, crushed and analyzed for necessary control of operations. Every step of the way the ore is tested. This is for control, to make sure the right procedure is followed all along the line. There's the first piece of gold we've seen, and it weighs but a tiny fraction of an ounce. At last the gold is made. That is, if you can call the result of all the mining, grinding, and processing you have just seen making gold. This is the end for the small briquettes of amalgam and the precipitate, the melting pot. With heat, the quicksilver is separated from the amalgam and the resulting crude bullion is taken out of the retorts. In this furnace, the gold precipitate is refined into crude bullion by melting. The impurities are removed by the slag. Next, the bullion is remelted and further purified, ready to be cast into gold bars. This is the final result of the vast operations above and below. Less than a week ago, this gold was imprisoned in hard and tough rock, thousands of feet below the surface of the earth. What miracles of science and engineering it took to recover this gold from the ore. 4/10 of an ounce of bright yellow metal is what you see here, and it comes from 1 ton of ore. 1 ton of ore mined with modern equipment, 1 ton of ore hauled and hoisted to the surface, 1 ton of ore crushed and ground to a fine sand, 1 ton of ore through the rod mill for amalgamation, through the great tanks for cyanidation. The coordinated effort of hundreds of men above and below the surface of the earth, complicated machinery, modern science, all working together so that 4/10 of an ounce of gold may be wrested from 1 ton of ore. But there are other things important to gold mining, necessary, vast, basic, all blending to a common purpose. Sand filling, for example. Here hundreds of tons of ore have been taken out. Something must be put back to fill the open spaces. Combating the great rock pressures which otherwise cause surface caving, and to protect nearby underground workings, these openings must be tightly filled. But with what? With sand from the mill. After all the ore has been drawn from the shrinkage stopes, the stopes are filled with waste, barren rock. Then sand is sluiced into the broken rock for a tight fill. The successful mining of marginal low-grade ores depends upon holding costs to an absolute minimum. Since 1931, homestake taxes have increased at an alarming rate, and with them costs. Consequently, great blocks of ore are left in the mine, lost forever, because the cost of reopening the stopes in the future would be prohibitive. The lighter area is marginal ore. The black is ore. Increased costs cause shrinkage in the mineable ore, shorter life for homestake, and inestimable loss to its employees and to the state of South Dakota. Another engineering department has a highly important function in the homestake mining operation, mechanical engineering. This department has to do with maintenance, service, and operation. Every year, this department makes and sharpens over 1.25 million pieces of drill steel for use in the mine. Special steels for 101 other uses are kept on hand at all times. Many kinds of special shop machinery are needed so that the mine and all other departments may receive prompt service and a supply of special parts and equipment. Over 4,000 feet of ventilating pipe are made annually to provide healthful ventilation at all depths. The foundry produces over 2 million pounds of iron castings every year. Repair work such as this for the maintenance and operation of hoists, crushers, conveyors, air compressors, mine pumps, and boilers is constantly going on. Work as delicate as adjusting and balancing a fine scale or the repair of massive equipment weighing several tons, it's all in the day's work for these skilled and experienced homestake mechanics. Here at the homestake coal deposit, the mining of coal goes on spring, summer, fall, and winter. Coal for homestake light, power, and heat. Hundreds of tons of dirt are removed daily to expose the age-old bed of coal. And then, deep down into the bed of coal, nearly 100 feet, goes the charge of explosive. There go thousands of tons of coal, one of nature's greatest servants harnessed for the use of man. Machinery for loading the coal onto endless conveyor belts, for transporting it to the tipple or sorting bin on the surface. Machinery for transforming it into power. Every day, 350 tons of coal roll out of the mine and into the chutes. Coal for light, power, and heat. Coal for the Kirk power plant at Homestake. Coal to turn the wheels of industry. Everything completely automatic, clean and efficient. Distilled water is used in the boilers to protect them against corrosion. Here it is made, 20,000 electrical horsepower, and distributed for heat, power, and light at Homestake. Water trickling down from the Black Hills is piped over the mountains, through miles of tunnels, to the surge tanks where imprisoned air is freed from it, to drop nearly 700 feet below into one of Homestake's hydroelectric plants. 59 million kilowatts each year from hydro plants and steam, enough to light all of South Dakota's cities, all used in her great industry, the mining of gold. New construction and improvements at Homestake require tens of thousands of sacks of cement, all of which come from South Dakota's Rapid City Cement Plant. Crushed rock in great quantities to keep pace with the company's needs. This is all supplied by the Lead City Crushing Plant. Bricks, hundreds of thousands of them for Homestake and for South Dakota, are made by private enterprise at nearby Belle Fourche. South Dakota raw materials for new construction. South Dakota raw materials for a great South Dakota enterprise. More raw material in the towering forests. These giants of nature are the backbone of the mining industry. Timber. Timber for the mines. Scientific methods are used in logging. No haphazard cutting nor waste in the great pine forests. Inspection before cutting. A weeding out process that gives the young trees a place in the sun. When the trees are stripped of their branches, they are loaded on trucks for transportation to the sawmill. No place for oxen or horses now. Big diesels do the work in good weather and bad. This big fellow is going to the mines. Out of the ground from a tiny seedling to a mighty giant of nature. Back to the ground to hold it up as man's great ally in industry. Timber for the mine, and a lot of it. What you see here is about 1 year's supply. All that lumber goes into the Homestake mine in a single year. You might wonder where it all comes from. It all comes from areas like this. But through selective cutting and reforestation, there is no denuding of the forests. Here is a typical reforested area. Yes, there's plenty of timber and plenty of beauty in the Black Hills for the generations of today and the generations of tomorrow. Homestake logging meets high standards of conservation in cutting, thinning, reforestation, and fire prevention. Trained men protect its own holdings and cooperate in emergencies on the public domain. Industry means science, raw materials, men. From the grizzled prospector of yesteryear to the great Homestake organization of today, a pioneer in the mining of gold, yes, but a pioneer in the development of a greater claim, the loyalty and contentment of its employees. Homestake pushes on. This modern hospital, equipped with the finest of medical and surgical apparatus, is not only for the Homestake employee. Here, his family as well receives advice, counsel, treatment, and care from an expert staff of physicians and trained nurses at no expense. A liberal pension system adopted by Homestake in 1917 is an added comfort to those nearing the sunset of life. And for the employees, training in safety, first aid, and mine rescue, an accident rate only 1/2 of that for the American mining industry as a whole. Play, too, is stressed at Homestake, and there's plenty of it for the employees and for all the citizens of Lead. This $300,000 recreation center was erected by the company in 1914 and includes a library with the knowledge of the world compressed into 26,000 volumes. And all this costs the community not 1 cent. These men are veterans, veterans of industry, veterans of Homestake. Every one of them has been employed for 21 years or more. Right now, there are more than 400 members of the Homestake Veterans Association. This venerable gentleman, Mr. William Lang, has worked with Homestake for more than 50 years, just a temporary job. If you're musically inclined, there's the band, and a good one too. Bass drum, big horns, piccolos, the whole works, and it makes good music. Happiness abounds, and why not? They are happy. Happy in the service of a company of which they are a part. Most of the employees of Homestake are homeowners, secure in the knowledge of constant, stable employment. Employment which has maintained a steady level through the years, regardless of the trials of the times. That is a basic Homestake policy. Yes, men are the most important thing at Homestake. Men from the north, the east, the south, the west. Men from the South Dakota prairies, men from lands across the sea. Men seeking life, liberty, and the pursuit of happiness under our flag and Constitution. These men know that they are a part of Homestake, a part of an institution that is as much South Dakota as the Black Hills country from which it has grown, a part of the great industries in the state which contribute so many raw materials to the operation of this enterprise. These men know that their success, the security of their families, and the 25,000 people in the great state of South Dakota who are directly or indirectly affected by this industry depend on the success and continuation of this great enterprise.